Okay, so take a look around you for a second. The device you're on right now, the lights in your room, maybe the car parked outside, they all share a secret ingredient, an unseen element that makes our entire modern world tick. We're talking about copper, and its journey from deep inside the earth to the very heart of our technology is, well, it's nothing short of amazing. So if I asked you what really powers the modern world, you might say electricity or maybe data and the internet, and you're not wrong. But underneath all of that, there's a physical element, a metal, that makes the whole system possible in the first place. And the crazy thing is, it's literally everywhere, hiding in plain sight. From the electric vehicle you might be driving, to the smartphone in your hand, to the power grid that lights up our cities, and even your refrigerator. Copper is the fundamental, conductive backbone of our lives. And it all starts with this, a rock. Just a plain old rock. It seems kind of impossible, doesn't it? So how in the world do we get from a piece of rock pulled out of the ground to the ultra-pure, high-tech wire inside your phone? Well, that's exactly the journey we're about to take. All right, our journey begins at a truly massive scale. We're going deep into the Earth's crust to get our raw material. So we start with something called copper ore, and the key phrase here is just enough. See, we're not digging up shiny nuggets of pure copper, not even close. We're digging up tons and tons of rock that has these tiny, tiny little flecks of copper-rich minerals scattered all through it. And how much is just enough? Typically, it's about 1%. That's it. To put that in perspective, for every, say, 100 pounds of rock we haul out of a mine, we're only going to get about 1 single pound of copper at the very end of this whole process. It's a huge amount of work for what seems like a tiny reward. So, this first stage is really all about brute force. I mean, we're talking about drilling and blasting to literally break up the face of a mountain. Then, these gigantic shovels and trucks, these things are enormous, come in to load and haul thousands of tons of this broken rock. And from there, it goes into a primary crusher that just smashes it down into more manageable fist-sized pieces. Okay, on to the next stage. This is where we figure out how to separate that tiny fraction of valuable copper from all that worthless rock. And this part feels a little bit like magic. To get the good stuff out, we first have to break it free. Imagine you have a cookie, but you only want the chocolate chips. You'd have to smash that cookie into a fine powder to get the chips out, right? Well, that's exactly what we do here. Those crushed rocks go into massive mills that grind them down into a powder as fine as dust. Now, this next step, flotation, is one of the coolest parts. It's basically a high-tech, super selective bubble bath for minerals. We're moving away from brute force now and getting into some really clever chemistry. So we mix that fine powder with water to make a slurry, and then we add a very precise chemical cocktail. There's a collector that makes the copper particles hate water, so they'll want to stick to anything else. Then a frother creates a nice, stable layer of bubbles, kind of like the foam on a latte. And finally, a depressant makes sure all the waste rock sinks to the bottom. The copper literally grabs onto the air bubbles and floats to the top, where we can just skim it right off. It's genius! So, after all that grinding, mixing, and bubbling, we skim off that coppery froth and dry it out. And what we're left with is a product that is much, much purer. We have made a huge leap forward. Now, that concentrate is about 30% copper. Think about that for a second. We went from a rock that was just 1% copper all the way to a concentrate that's 30% pure. We've successfully separated the wheat from the chaff. All right, next up, we take that dark, rich concentrate and we turn up the heat a lot. This next part is a trial by fire. So the concentrate is fed into a massive furnace. We blast it with super hot oxygen-enriched air, which kicks off a whole bunch of chemical reactions. Basically, the iron and other impurities bond together and form a waste material called slag, which floats on top and can be skimmed off. What's left behind is a heavier, much more valuable molten liquid called copper matte. This whole fiery process is really a two-step dance. First, smelting gets us that copper matte, which is already up to about 75% copper. Then, that molten matte is moved to another vessel, called a converter, where we blast even more oxygen through it to burn off any remaining sulfur. The result is something called blister copper, because it has these little gas bubbles trapped in the surface as it cools. And at this point, we've reached about 99.5% purity. Now, that sounds pretty much perfect, right? But for the high-tech world we live in, for our electronics and computers, even that tiny 0.5% of impurity is a deal breaker. It can disrupt an electrical current and cause major problems. So believe it or not, 99.5% still isn't pure enough. So let's move on to the final high-tech stage. This is where we get that last little bit of impurity out and achieve near perfect purity. This process is called electrorefining, and we're basically going to use electricity to move the copper atoms one by one. We cast our impure blister copper into a big slab called an anode and hang it in a bath of acid. Right next to it, we hang a thin, perfectly pure sheet of copper called a cathode. When we run an electric current through the bath, pure copper atoms dissolve off the impure anode, travel through the acid, and plate themselves perfectly onto the pure cathode. All the junk, impurities like gold and silver, just falls to the bottom. And there it is, the final product, LME-grade copper cathode, which is at least 99.99% pure. LME stands for the London Metal Exchange. It's the global standard. This unbelievably pure metal is the true foundation for modern electronics, renewable energy, and communications. So we've finally made it. We have this perfect slab of ultra-pure copper. But a slab of metal by itself isn't all that useful. What does it actually become? How does it get into our world? Well, that pure cathode is melted down and then fabricated into all the essential components that literally build our society. It's drawn into the miles and miles of wire needed for our power grid. It's wound into the motors for electric vehicles and home appliances. It's formed into tubes for plumbing and air conditioning. It becomes everything. Let's just zoom out for a second and appreciate this whole journey. We start with a 1-ton chunk of rock, a literal ton. And after all of that blasting, crushing, grinding, floating, smelting, and refining, we end up with just 10 kilograms, about 22 pounds, of this indispensable metal. It is an absolutely incredible transformation. You know, going through this entire complex, energy-intensive process really underscores just how precious copper is. And as we build a cleaner, more electric future that demands more of it for EVs, wind turbines, and a modernized grid, it raises a huge question for all of us. The question isn't just how do we make copper, but how are we going to find enough?